Let's take a few minutes and look at our 4 practice questions over 2 sample T procedures. So questions 33 and 34 are about deciding if the conditions are met in order to complete a significance test or in order to construct a confidence interval. Is there a difference between the average number of shoes that female and male teenagers have? Well, this is an observational study. So we have 2 samples, size 20 each. They are independent random samples, independent in that one of the samples is from males, one of the samples is from females. Because this is an observational study and the sample sizes are 20, 10 times 20 would be 200. So we have to believe that there are more than 200 males or 200 females at the school. That's reasonable. So when you look at the sample data, though, understand this is going to be about an average or a mean. That means the normality condition is about having a large sample size for males and a sample size for females of 30 or more. So notice we only have samples of size 20. That means when we look at the sample data, we have to make sure there aren't outliers and there aren't skewness. Well, in the female data, I don't see outliers or necessarily any skewness there, but there are definitely outliers, potential outliers indeed, for the data for the males. So as a result, a 2-sample T procedure, building a confidence interval or doing a significance test wouldn't be appropriate using the data in question number 33. And that's because the normality condition isn't met for the males, because it's pretty clear there's at least one outlier in the data for the males. So looking at the next question, number 34, is there a difference between the average? So again, this is about means. So household size in South Africa versus the United Kingdom. Well, here we have samples of size 50. They're independent random samples, independent in the sense that 50 of them are from the United Kingdom. Randomly, we have selected 50 from South Africa. You can't have a household in both South Africa and the United Kingdom, so they are independent of one another, random samples. This is an observational study, so 10 times 50 would be 500. Certainly, there are more than 500 households in South Africa and 500 in the United Kingdom from which you could have sampled. So now it's about the normality condition. So again, this is about an average. So this is about means, and the normality condition here is to have a large sample size, a sample size of 30 or more. So these are large samples. They're both samples of size 50. Now I know when you look at the data, you may have outliers in the data from South Africa. That's not really a concern here because the sample sizes are large. They exceed 30. So for both samples, they're both large. They both exceed 30. The independence condition then, the randomness condition, the normality condition, they are all met here for question number 34. So you could use a 2-sample T procedure here. You could do a 2-sample T test, or you could construct a 2-sample T interval. So question number 34, who talks more? So the hypotheses here, if on average the number of words that males and females speak during the day, if those are the same, the difference would be 0. So we are looking for evidence of a difference between, on average, how many words that males speak in a day versus how many words that females speak in a day. So we're simply looking for evidence that the difference between the 2 population parameters is something other than 0. So in terms of the conditions, we have 2 independent random samples. They're different genders. We have 56 male and 56 female students from a large university. Because this is an observational study, we should check the 10% rule. So because this is a large university, certainly there are more than 560 males and more than 560 females at a large university. And with these sample sizes, the sample sizes of 56 for males, 56 for females, these are both large sample sizes. They're both 30 or more. So the normality condition is also met for both samples. So the randomness, the independence, the normality conditions are met, and we are ready to proceed with our 2-sample T test. Important. Always name the test. It is perfectly acceptable to use the calculator to get your t-score, to get your p-value. Please also remember, write down the degrees of freedom. So we're now ready to write our conclusion. So this is a very large p-value. Our p-value is 0.8. That's certainly greater than 5%. This is not an unlikely event, so we do not reject. We fail to reject the null hypothesis, and then we should write about the alternative. So there is not sufficient evidence to conclude there is a difference between the average number of words spoken in a day by male and female students at this large university. Last question, number 45. So comparing the degree of reading power, the DRP scores for the activities and the control groups. So if you compare the data, so understand in the first part of the question, this goes all the way back to the very first unit in AP statistics, where we can look at these graphical representations and compare the shapes and the centers and the spreads, but it's important to do it in context. So when I look at these shapes, I don't see either shape as being strongly skewed. Maybe the activities group might be skewed a bit to the left, whereas maybe the control group is a bit skewed to the right, but I don't see anything unusual in terms of the shapes of these data sets. So in terms of the center, choose a particular measure of center, and because of the way the data are presented, it's easiest to talk about the median here. So I said that the median DRP score is higher for the activities group compared to the control group. You could have said that the median DRP score is lower for the control group than for the activities group. That would be perfectly fine. But give a specific measure of center, put it in context, and then give a direction. Higher or lower, greater, less. So in terms of spread, again, in this graphical representation, the IQR or the range, one of those is the easiest to describe here. So I wrote that the IQR is lower for the activities group, or that's the treatment group compared to the control group. You could have also talked about the range. The range is lower for the activities group compared to the control group. I already put context up here when I talked about the center, but we could have said the IQR for the DRP scores or the range for the DRP scores. That would have been perfectly fine. But as long as you have context somewhere within your comparisons, at least on the AP exam, you should be in good shape. And you could have also said the IQR is higher for the control group compared to the activities of the treatment group. You could have said the range is higher for the control group compared to the activities group. You could say it either way, and that would be perfectly acceptable. So in terms of unusual features, we don't see necessarily any evidence of outliers or gaps in these two data sets. So I think we have a complete description here of comparing shapes, centers, and spreads. So now the second part of the question isn't just about a comparison, it's about looking for evidence. So understand, is the mean DRP score significantly higher for students using the activities? We're not saying for students in general, we're not saying for students in these classrooms, we mean for students in general. So is the mean DRP score significantly higher? So you could also have phrased this question, do we have evidence that the mean DRP score is significantly higher for students that use these activities versus students that don't? So we have a direction. So we're looking for significantly higher. So we know then how to write our hypotheses. So the null hypothesis is the hypothesis where nothing special is going on. The null hypothesis, and you could write it the mean DRP score for the activity group minus the mean DRP score for the control group. You could have done control group minus activity group. That's fine, the way that I've written it. The bottom line is the difference for the null hypothesis, we're assuming that there's nothing special. There's no difference between the true mean for the activities group versus the true mean DRP score for the control group. So the difference is 0. So the order in which you write the means, activity versus control, that order will dictate the direction of your inequality symbol here. So remember, we were looking for evidence that the scores are significantly higher for students using the activities. So we're looking for evidence then that the mean of the activity group minus the mean of the control group is greater than 0. Again, we're looking for evidence that the activity group has a higher mean. So that would suggest that the difference between these two means would be positive. Now understand, if you had switched the order, if you did mu control minus mu activity, mu control minus mu activity, if you had switched that order, if the activity group were second, then we would be looking for differences that are negative, and this would be a less than alternative. Either way is a perfectly fine way to complete the test and to write your hypotheses. So in terms of the conditions, this is not an observational study. This is an experiment. So we have two independent random samples that are created by random assignment. We are creating independent random samples essentially by randomly assigning the 44 third grade students either to a treatment group, that's the activities classroom, or to the control group, the control classroom. So in terms of satisfying the randomness condition, it is perfectly fine just to state that we have random assignment of 44 third grade students to treatment and control groups. This is not an observational study, so you do not need to check the 10% rule because we are not randomly sampling from populations of students that use the activities versus populations of students that don't use the activities. That's not how the design of this study was set up. This is an experiment, so you don't have to check the 10% rule. Normality is important. Now understand the sample size in the activities classroom was 21. The sample size in the control classroom was 23. Those are both small samples. They're both below 30. They're less than 30. Now, that means then that for the normality condition to apply, we have to check the data. That's why in Part A, it's important that you had graphical representations of the data, because we can say that in the box and whisker plots, we don't see outliers and we don't see any serious skewness. So because of that, even though the sample sizes are small, with no outliers in either sample, with no serious skewness in either sample, the normality condition is met and we can proceed with our two-sample t-test. So in part B of the question, so to complete the two-sample t-test, putting the data into the calculator, so we have a t-score of 2.31, we have a low p-value of 0.013. Remember, always write down your degrees of freedom. Tests involving means, t-tests, or confidence intervals involving means, t-intervals. Those always have degrees of freedom. Make sure you write that down. So with this low p-value, 0.013, that's less than 5%. This is an unlikely outcome, so we do reject the null hypothesis, and then you should write about your alternative hypothesis. So this last sentence is about what we believe now we may have evidence for. So there is sufficient evidence to conclude that third grade students using these reading activities achieve a higher average, a higher mean DRP score than students that don't use them. So we're basically writing about the evidence that we have for the alternative hypothesis. And you may put it in your own words if you want to, or you can use the words in the statement of the question in order to write that last part of your conclusion. And both for our class and for the AP exam, I think that's probably the easiest way to go. So the last part of the question is really important. Can we conclude then that these new reading activities, so whatever these activities happen to be, can we conclude that they are actually causing the increase in the mean DRP score? So in other words, does this study give us evidence of cause? So remember, there are two primary types of studies that we have learned in AP statistics: observational studies and experiments. In an observational study, you can have and detect an association. You can see a pattern. But in an observational study, you don't have evidence of cause. You need an experiment with random assignment to treatment and control groups to believe that the treatment may be causing the effect that you are observing. And that's what's happening here. Yes. Do we have evidence of cause? You may say yes in this situation because this is a randomized comparative experiment. So it's an experiment where we have multiple groups so that we can make a comparison, and we have random assignment into the treatment group, the activities group, and the control group, the group of students that aren't using these specialized reading activities. So indeed, in this study, cause is suggested by this statistically significant conclusion. What I really like then about question number 45 is this question over these three parts actually spans 3 units in this course. So the first part of this question is simply about comparing the data from the treatment group and from the control group, comparing the shapes and the centers and the spreads and looking for any unusual features like gaps or outliers. So the second part of this question then is about doing a significance test, a two-sample t-test, where we're looking for evidence that in fact the means are different, that in fact the activities group has a higher mean DRP score than the control group. But then the last part of the question is about going to our unit about studying the difference between observational studies and experiments. If you want evidence of cause, you need a well-designed experiment, and a well-designed experiment can be called a randomized comparative experiment, because in a well-designed experiment, you always have random assignment to treatment and control groups, and you have multiple groups so that you have a basis for comparison.